really ready to accommodate whenever a change really comes into it. And to do that, collaboration is a key thing, because the collaboration is not only between the people, is not only in the process, but it has to be part of our journey. So the key question before we go through the collaboration is about where really cooperate. And there's a distinct difference here between collaboration and cooperation. Collaboration is when a group of people really work towards a common goal and a vision. And that was really amazing because we saw that in place just a few minutes ago. Amazing work, people working together. But at the same time, when a group of people work to support each other's goals and vision, then this has been defined as cooperation. Now, do these two really worlds come together? Is a key question, because this is coming where the social sciences actually is coming in place. And in fact, what do we really mean and what is happening in reality? So in fact, the humans try to communicate with the group members by using a communication strategy. Businesses by default set up their own communication strategy from the operational level all the way to the decision making. But the purpose of the communication strategy is not only to help us on how to make the decisions, but it's about how will I be able to obtain and acquire the data and transfer them to valuable information where I can visualize them eventually, and however, to be able to have a better understanding of what's going on. This hierarchy of human understanding plays a significant role in construction. We know over the last, let's say, approximately 15 years, we are in a position of being able at the moment to use the ISO 19650 over the last 5 years, but over the less than 15 years, we are going through the need of designing and developing the state of the art of common data environments. But the question here is, people, wherever they are based in this planet, they try really to cooperate and to share the data, regardless the format, regardless the location. However, can we make these places, these virtual places, really to become more intelligent? And what is collaboration really? And what makes collaboration special? Is it about collecting the data? Is it about processing the data, storing the data, and sharing the data? What data? The project data at any format. The question is, do people know really how to collect the data? Can you understand really the difference between the data and the information? Or how are they going to process the data before or after they store and share them? Data is the first element of the hierarchy of human understanding, and we tend to forget that. If we want to become intelligent, if we want to create intelligence in our systems, if we want to take the things in a stage further, then this is the key. And as a matter of fact, people and human, how much data really can process. Our minds are really visually wired. It's not something that is not happening. And on this basis, according to research here, it has been found out that 80% of the text on most pages doesn't get read. I bet you receive an email, you don't read it that thoroughly. 90% of the information transmitted to the brain is visual. Why do we see all this social media really to become big thing in our days? 10 seconds can be really much more meaningful to something that can last about 5 minutes to go through by reading it. We retain 80% of what we see, on which the 20% of what we read and 10% of what we hear. The human brain processes images 60,000 times faster than a text. And Google's, in fact, receives approximately 70,000 search queries every single second. Imagine what machine we really need in the backside in order to be able to process these things, all these inquiries, and this has been growing and growing and growing. In 2018, Google Images account for 22.6% of all internet services. And finally, the brain can identify images that can be seen for as little as 13 milliseconds. These numbers are real estimated, though, numbers, and these really take in place where, in fact, and how common data environment can help us as humans, okay, to visualize what we see and to make more informed decisions. Here, there's a very good question. Is this going to happen always by the humans, or do we try really to give the power to switch that over the machine? Well, to be honest, the way and the speed we are moving at the moment, if we compare the human brain and the common data environment, then what we see is a definite integration. And the answer to the previous question is yes, that's the intent. And the question is about that to do that, we need to integrate the technologies. In a research conducted in the past with my colleagues, we find out that integrated collaborative technologies enhance team collaboration by fostering a culture of shared access to information. This promotes mutual understanding and knowledge sharing among stakeholders, regardless of location and the time. Hence, it empowers them to actively manage the project, optimize the interactions, and quickly address the potential issues or uncertainties. And in construction, these address potential issues and the uncertainties is a key aspect. We need to make assumptions by default from the day zero of a project, even as an idea. And at the moment, there are so many uncertainties that we don't know really what we really know and how we can really forecast. So we need to be in a position to make sure that data can become really the commodity that powers artificial intelligence, because artificial intelligence is related to computations, is based on a set of data inputted by either a human or a machine. So here's a good question. Is artificial intelligence a software? Is about algorithms? What is about? But AI refers really to a simulation of human intelligence in machines, programmed to think like humans and mimic their actions. It encompasses a variety of subfields, including machine learning, neural networks, natural language processing, and robotics. And AI can perform really tasks such as recognizing the patterns, understanding language, and making decisions. And the best thing is not going to be above 18 years old. I have a baby, he's 25, 26 months, and what we'll be thinking for him as a Christmas present, is to buy a robot so for him to get used to it. Now, if it's a good thing or not, we don't know. But on a recent survey by the American Institute of Architecture, it shows that architecture firms are slowly adopting the use of AI, but anticipate the AI to be a significant tool for serving the clients in the future. So imagine now a baby, 2.5 years old, okay, 2.5 years old, when he's going to be the age of 18, how far really can go and utilizes all these technologies in a way to move forward. So here we have some food for thought. How is an architect related to the above? And the second, how could we really how could the development of a collaborative culture really impact the design computation culture? Well, here we have to understand one thing. The architect is not coming only from the artistic perspective, okay, but is coming also to shape a culture that can really uh, stigmatize, but in a good way, the future. We can see this from the ancient years of the buildings in the past, okay, all the way to our days. So the architect, at the end of the day, is instinctively linked to the realm of design computation culture, and the modern practice of the architecture increasingly relies on computational tools, techniques, and methodologies to design the capabilities to optimize the building performance and streamline the construction process, as we saw that before from our colleague. And on this basis, the architect's role in design computation culture is coming in the way to offer to the architects to engage in a more dynamic simulations, parametric models, and algorithm-driven designs. We saw that from Carlos videos, amazing. And this is what is happening as a matter of fact. So by integrating computation into the design process, architects can really explore a wider range of design possibilities. You know what is the best thing? Zero risk, and make more informed decisions. And this impact is because collaboration by default encourages the sharing of expertise of the tools and the methods across disciplines. So that means whomever has been involved can have an input on be able to deliver something that is achievable. And achievable is a word that is part of the SMART objectives that we want to have on a project. So to achieve something is really critical in the design, and not only from functional perspective, but also from aesthetically perspective, sustainable, efficient, and resilient. So what is the effects now here? In this occasion, we have knowledge sharing, so leading to rapid advancements, interdisciplinary integration, optimized solutions, and finally shared resources with high-end simulation and analysis live, ad hoc. But in this occasion, what is happening in a case that we have a 3D beam, in fact, example? So what we find out in the research we did with my PhD students in China, the University of Nottingham, is that if I am in the level of development 350, then I should be able to understand the implications into my business and my practice. And this is something that is really missing sometimes, and sometimes in many occasions, because architects, they're designers, they are artists, they're trying to think out of the box. But at the same time, they have to think, what is going to be the impact on my business practice? So as a summary, architects integrate computational tools and methods into the practice by fostering collaborative culture that becomes vital. And collaboration not only enhances the quality and scope of architectural design, but also ensures that the benefits of computational design are fully realized, driving innovation in the industry. If I have some spare time, I will be happy to show you an example of what we did in terms of integrating robots and building information modeling as a snapshot of this presentation. Am I having